Welcome to the last of the videos on Numpy before we hit the heady delights of matplotlib. And this video is mostly on advanced indexing of 2D arrays. You will have seen advanced indexing of 1D arrays, and that can be a little tricky at times. 2D array advanced indexing can get really very tricky, and so I'm going to skim over some of the detail and focus on the important stuff, the easier stuff and the most useful stuff. So just to remind you for a start, if I run this script here, that gives me some data to play with, nums. So if I do nums where nums greater than 3, that was a use of advanced indexing in 1D array cases. And the subscript there, nums greater than 3, looks like this. It is an array of booleans. And those booleans are used to select particular items. So the key idea really in advanced indexing is selection. You're trying to pull out stuff that is of particular interest, usually programmatically. So we'll focus in the case of 2D on pulling out arrays and columns that are of particular interest to us. So I guess with data there, it's probably not a surprise to you that if I pull out, if as a row index I use say 3, 1 as my row index and all columns, that what I get is the row number 3 and row number 1 from that data array. Those are zero origin, of course. I can also omit the last subscript because the standard indexing rules for 2D arrays assume if there's a missing index, it'll use a colon. So I get the same result. So that first index is a row selector in this case. I can of course run the same thing the other way. I can select columns 3 through 1, but in this case I can't omit the colon and I have to write it like that, and that gives me columns 3 and columns 1 in that order. I can also index by using arrays of booleans. In this case I have to get the number of booleans to match the number of rows or columns depending on what I'm selecting. So true, false, 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 true as a subscript to select rows, and then using an implied colon gives me the rows that correspond to true in that list. So in this particular case the first row is true and the last row is true, so I get those first and last rows. So I'm going to skip over some of the details here. You can look through them if you like. They're getting into a few complexities that I'd rather not get involved in. I'd like to focus on this bit, which is the conditional extraction of rows or columns, for which I'd like you to imagine that this data array here is something read from a CSV file, for example, that has -1 to indicate bad data. This might be readings of rainfall, and there might be a convention that if the equipment's out of service, that a -1 is always recorded. A common convention. Doesn't work too well with temperatures. It's great for a lot of physical quantities that can't be negative. So in a case like this, you would often be interested in pulling out the rows that had bad data, or possibly the rows that didn't have bad data. Let's look at how we can do that. So we know that the bad data is where the data is equal to -1, for example. And you can see the bad items showing up here. Remember, this is an operator on the entire array, checks every item against 1 for equality, and sets it to true in the matrix if the original value was -1. So we've got all those trues just in the middle there where the -1s were. If I want to use that just to extract, for example, the rows that are of interest to me, these might be different days in which stuff is recorded, then I can find the rows of interest using that np.any. Or I showed you np.all, I'm now going to show you np.any. So np.any is a function that takes a matrix, normally of booleans. It's better to think in those terms, so I'm going to give it one of those. It takes this matrix of booleans, and in this trivial case it returns true if any of them are true, which of course is definitely the case, but I'm interested in which rows have that. To find out, to operate on rows, remember this technique of using an axis. So I set the axis equal to 1 in this case, and I get a vector, one item per row, which is true if any of the items in the row are -1. So there you see we've got two rows in which we have a true value, that is any of the items in the row were -1, and I could use that, I could call that the variable bad rows. And of course I can use bad rows as a subscript, so I can say the data of the bad rows. And that pulls out the two bad rows. If I want the good rows, then probably it's more logical to start over, so let's do that for a start. So if I want the good rows, they're going to be the rows for which all of the data is not equal to -1. So this is going to be an np.all, where the data is not equal to -1, and I'm interested in rows, not columns, so I use axis 1. So the good rows should hopefully come out to all the cases where, namely the first row and the last two rows are good rows. So in both cases I can pull out the data in that way. There are ways of getting from good rows to bad rows. I could, for example, use the np.logicalNot on the bad rows, in which case it negates all the elements in bad rows. It's a vectorized version of the not function. And I could have used that as a subscript instead of going back to good rows, but it just makes the logic more confusing. And I can do the same thing with columns, but I'm not going to bother here. Hopefully the idea is clear, and it's relatively easy to do advanced indexing at that level. If you're trying to do it for more subtle stuff, well, it gets quite a lot harder. So I'm not going to go there. Last slide on the subject of NumPy before taking a peek ahead, matplotlib, yeehaw. Before we get there, what else is available in NumPy? Have we done it all? We've done the ND array type, but even there we've only done a bit of it. It's a very large package, and it's full of stuff for very experienced data analysts, whatever. So just as a quick peek here, I've said here NumPy also offers vectorized versions of most math functions, plus many others. So if we were to open that link in a new tab, and I think I would encourage you to do some browsing there. Woo, what happened? I don't know what happened there, but I've got there now. At any rate, there it is. So there's a heap of stuff here. I don't have time to go through it all, but I do encourage you to have a look. So ones and zeros we've done, creating arrays. There's a whole heap of other things, ranges of data, a range, linspace and so on. But there's some other things we haven't done. There's quite a lot of stuff in manipulating arrays that we haven't touched. In fact, there's one thing that may actually be important to you, and sometimes that's joining arrays. So if I want to stack arrays, one on top of the other, for example, there's from memory there's HStack and VStack, but you can have a look at those, and that can be useful when you're assembling stuff, or even tiling arrays, bloink, 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 tiling arrays to create a bigger one, and rearranging, removing stuff. You can manipulate arrays in ways that I haven't described in the lecture notes. And we won't be covering them in this module, but it's good to look at them. It's just a matter of knowing what the functions are. There's binary operations. You can do string stuff as well, but I was skipping over all of that. We're not doing that in this module. Date time support, some manipulations of various data types, linear algebra, fast Fourier transforms. Where's the linear algebra stuff? Down here, NumPy linear algebra. There's a lot of stuff. I do encourage you to look through it. We certainly don't have time to do any more of it. That's most of the stuff we've skipped in NumPy. So let's just go back here. That was all of that stuff. I should have mentioned the np.random, which is quite useful when you're creating random samples from various distributions. There is a matrix type that I didn't talk about, in which star means matrix multiply. It's a sort of subclass of NP array. I do encourage you not to use that. It's semi-deprecated. They're trying to figure out how to get it out of NumPy again because it's created confusion. So rather than ever using the matrix class, please just continue to use the ND array class with n equals 2 and the @ operator for multiplication. And there's one other thing I want to mention, and that's the vectorize method or function of the NumPy module, which lets you take any Python function at all if you don't have a vectorized version. For example, a function that takes a float to a float of any sort, or float to a ball, or anything else really. If you've got such a function and you wish to apply it to all elements of an array in one line, then you can pass it in as a parameter to np.vectorize, and you get back a vectorized version of that function. You can read about it if you want to. And that's it for NumPy. That's all we're going to cover in this module, and the excitement starts with the next video on plotting arrays. Thanks for watching. Bye.